If everyone can hear me, I think we can start today's webinar, which will be about the IDEA connection interface in ConSteel 10. First of all, let me thank you for the participation on this webinar. Let me introduce myself. My name is Roland Doka. I am working as a support engineer here at ConSteel Solutions Limited. And before we start, here you can find some practical notes about the usage of GoToWebinar. With this red arrow button, you can hide the side panel, and at the questions tab, you can ask questions during the webinar, and I am going to try to answer these questions at the end of the webinar. Please, if there is a problem with the audio or anything, just ask a question, and I'm going to try to watch them. Okay, so this webinar is the part of the autumn webinar series of 2016. We had another webinar in this series scheduled at the 27th of October. That webinar was about the slab reinforcement calculation and export in ConSteel 10. This webinar is already uploaded and available on our YouTube channel. Today's webinar will be about the high-level interface between IDEA Connection and ConSteel. Our autumn webinar series right now is mainly covers the main functions of ConSteel 10, the first service pack of ConSteel 10. The service pack is already available on our website, consteelsoftware.com. And about the content of today's webinar is, first I'm going to show you how you can define link between the IDEA connection and ConSteel softwares, and then I will show you how you can create and design a joint in IDEA from ConSteel. I will also show you how are these IDEA connection joints are stored on your computer and how they are linked to a ConSteel model. And also I would like to show you how you can modify a placed IDEA connection joint from ConSteel after you created it and designed it, but some modifications happened in your ConSteel model and you have to optimize your IDEA joint later. The possibilities for joint design in ConSteel is now extended, but currently CS joint and IDEA connection can be used for joint design too, but it is important to know the advantages and disadvantages of both softwares. First, the CS joint module or CS joint program is based on component method of the Eurocode, which is a good method. It gives you quick solutions and quick calculations, since these are parametric calculations, but they are only good for standard topologies and for standardized joint models. However, IDEA connection software is a finite element based software. It is good for standard and general topologies too. It uses the newly introduced CBFAM method, and the main advantage of IDEA connection software is that it gives a solution for nearly all kind of joint topologies, but it is a little bit slower compared to a parametric component method calculation. You have to create manually joint models one by one, but it is a very good software, and it is very useful to those joints that you cannot create or design in CS joint. Both software gives you automatic evaluations, and both software gives you documentations. So that was the presentation part of this webinar. I would like to move on to the practical part. So first, I would like to show you how you can define the link between IDEA Connection and ConSteel software. When you open up a ConSteel, you have to go to the Options menu, and at the Options menu you have to select the Export label. Here you can find the here you have to define the installation path of IDEA Statica 7. You can do it with this folder button at the right side of this edit box. By default, the installation path is the program files /IDEA /Statica 7. After you gave the installation path, you only have to click OK, and from now on you can use IDEA Connection for joint designs beside CS Joint 2. IDEA Connection is integrated into the CS Joint module of ConSteel. So all of the CS Joint related functions work on IDEA Connection Joints 2. So basically CS Joint functions are represented at the Structural Members tab here. And if you want to create a new joint, as usual, you have to use the Create Joint by Model function. You only have to select the function, click on the joint which you want to design, and then you get this Build New Joint Object dialog. And at the right side of the dialog, you see that there is a CS joint solution for this particular joint, and in every cases where CS joint solution is not working, or there are no CS joint solutions, you will find the IDEA Statica connection too. So if you select this IDEA Statica connection, which means that you want to design this joint using this software, you have to select the main girder first for the joint, because in IDEA Connection you will have a supported member and the rest of the members are unsupported. But with this drop-down, from this drop-down menu, you can select the supported member, which will be the supported member in IDEA Connection. So let's say beam 1 is okay for us now. Okay, after that, only click on the Create and Place button and place the joint back to the structural model with a simple click. As you can see here, the graphical visualization tells you which part of the member is the main girder. Currently, this is the main girder, the right beam, and the left beam is the unsupported part, will be the unsupported part in the IDEA Connection model. Okay, if you placed the joint to every places where the same geometry exists, because you can place one joint to several places, you only have to click the End Joint Placement button here, and after that IDEA Connection will open up, and you can start to design the joint in IDEA Connection. Okay, as you can see now, here you can find the joint model. Geometry geometrical parameters are imported, so we have the proper cross-section. We also imported the alignment of the members. Currently there were no offsets defined in ConSteel, but if there would be offsets, that would be imported to IDEA. Also, if you would have not an ended type of joint, but a continuous one, that would be imported from ConSteel to IDEA connection. The other thing that IDEA imports from ConSteel is the load effects. Okay, but currently analyses were not ran in ConSteel, so I will go back to ConSteel. Just click on the close button and run an analysis on the model. And then I'm going to reopen the IDEA connection joint. By the way, this is how update works on the placed IDEA connection. So joint loadings will be updated if you rerun an analysis and reopen a placed IDEA connection joint. So if I'm right, if I click to the load effects button, yes, the loads are imported. Currently I have only ran one load case, but the loads are imported from that load case. Okay, and from now on I can design the joint. What can be done with two ways. First, and this is what I'm going to do right now, I can apply a template on the joint, which is a preset of manufacturing operations. I only have to click the Apply Template button, select the bolt assemblies, click OK, and I have to select a proper predefined or user-saved template for the joint. Right now this hinged beam-to-beam connection will be OK. And after the apply, as you can see, the manufacturing operations which are saved in this template are applied on the joint. So this is the first way to design a joint in IDEA. If you have a template or you created previously a joint with manufacturing operations and saved those manufacturing operations into a template, you can apply them, but right now I only apply the template. In the next step I am going to show you how you can apply different manufacturing operations just in a simple joint. Okay, but if you have your manufacturing operations applied on your model, you can go to the checks and start the calculation of this joint. Right now everything is adequate. We can check equivalent stresses in IDEA connection. We can check plastic strains because the IDEA connection checks if the plastic strain of the plates is below the Eurocode recommendation of 5%, or if it's above this 5% plastic strain, it will give you an error and you have to modify the joint. But you can check the equivalent stresses too. You can check bolt forces. You can check mesh. You can check the deformed geometry of the joint too, if you want to. But currently this joint is adequate, and we can go back to ConSteel and continue the structural design. If you close the program, it will ask to save the joint data. Click OK, click yes. And from that point, how these IDEA connection joints are stored on your model, this is what I'm going to show you now. If you open up the folder where you where is your ConSteel model that you are working on, you see that two new folders will be created with the name of the ConSteel model file. First one is currently the whole with Podium is the model name, the ConSteel model name, and the IDEA IOM folder contains temporary files with the results of the ConSteel calculations and export data. This is only a temporary folder, but in the other folder, the IDEA joint folder, you can find the IDEA connection joints, IDEA connection models that you created in ConSteel. And if you want to work on another PC but with your ConSteel model and the attached IDEA connection joints too, you have to move all of these folders and your model file too. So they have to be in the same place in another computer. Okay, let's go back to our ConSteel model, and let me show you that how are these IDEA connection joints are listed in the edit joint dialog. This model is a 3D model. We have several placed CS joints, but there were some joints what we wanted to design in IDEA connection. For example, I want to design this joint at the corner. I already placed an IDEA connection joint to this place, and this joint and the previously created beam-to-beam joint is listed below the previously created CS joints. And from this tree, you can open up IDEA connection with a simple click. So I want to design this beam to column with diagonal joint, what I have placed before, recognized it and placed back on the model. From that point, it is listed here at the joint tree. I want to design it, so I simply double click on this graphics. IDEA connection will be opened up. It takes a while for the first time, for the first start of the joint model. And then we can start the definitions of the manufacturing operations. Right now, as you can see, of course, loads are imported from the ConSteel model, and the geometric parameters are also imported properly. So right now, I cannot apply a predefined template. If I open up the template window, I cannot find any predefined templates for this particular joint. So what I can do now is to define these manufacturing operations one by one, and then I can save it as a template so I can use it in the future if I have a similar joint design later. So let's start to define new manufacturing operations. First, I'm going to apply an end plate to the DM8 member. Let's click this this button here, choose the end plate manufacturing operation. Let's choose the first member, the member which is on which it is applied, the end plate on which is applied. Okay. Let's increase the length of this end plate. And let's put a bolt to the end plate. Okay. Next one, I am going to lengthen the DM7 member of the joint because it is set to a default value 0, and I'm going to lengthen this member to 600 millimeters. Go back to the design, and I am going to apply a connecting plate manufacturing operations, no, a widener operation for the end plate and the beam, and I will connect this member to this widener later. So first, this widener will be on DM7. It is related to not a member, but it is related to an end plate, to the end plate. I only need the webs, parts on the webs, but not both, only the front one. Dimensions are a little bit larger. Okay, and I'm going to choose chamfered geometry. Okay, next I am going to define a connecting plate on DM7 member. So let's add a new manufacturing operation. Let's say that it is applied on the DM7 member. It is connected to an existing plate, which is the widener number 1. Let's set the geometrical parameters. It will be a notched type. And let's give some bolts to it. Okay, let's chamfer this tongue. I go to the editor, choose a chamfer, define the values for the chamfering, and then I'm going to apply the settings. We are almost done. We only have to handle this last member. For this member, I am going to use a cleat connection. For what? I have to define the member on which is applied, which is the DM6 right now. It is on the web, and it is connected to the DM5, which is our column. The profile cannot be EH220. It has to be an L profile. So I am going to choose an angle section, for example, L70 with the 6 mm wide plates. Okay, we are almost done. Yeah, so the set of manufacturing operations are defined. I can start the design, and also I can save this template, so I will be able to use it later on joints with similar geometrical topology like this. So in the next time it would be much faster to design this joint. And if everyone is set it properly, the calculation should be run. I guess the joint will not be optimized well, but I don't want to optimize it right now. It takes some time. But this is the main steps of the joint design in IDEA Connection from ConSteel. So if I design the joint properly, I can save it and then go back to the ConSteel model, continue with the design of the structure, and if something changes in the ConSteel model, new loads are applied or something like that, you can always choose the IDEA Connection joint from the joint, and you can reopen it, and with this the loads will be updated and you can optimize it again if it's necessary. Yes, so this is how modification of previously defined joints works in ConSteel. And yes, this is what I wanted to tell you in this webinar. I don't know if you have questions. I am ready to answer them.